All right, let's get it. Cool. All right, so I don't know how to add to a vector yet. All right. Where were we before? Wait, I totally didn't save the right one. The fuck? I had like a bit of syrup or something on my lip. That was weird. It didn't taste like nothing. That was weird. All right. Wait, I did have this bookmarked? Oh, I bookmarked an anime the other day. Oh, because the music's really good. And then this bookmarked there. I'm just retarded. Unlucky. All right. That's not unlucky. Skill issue. Okay. Ah. So we had different syntax for creating a vector. Or creating an array, but a standard vector that value initialized a number that we specify of elements instead of creating one element with that number. So oh wait, hold. Oh, oops, this is wrong. I is nothing. And while I is less than vector.size, because it needs to be less than plus plus. This needs to be unsigned. Nice. But if I instead made this cool. What about oh. Gotcha. So when using direct initialization, this is specifying the size in one element. Or sorry. Yes, this I just said two conflicting things. This is specifying the length, how many elements there are supposed to be that are going to be value initialized with 0. Whereas list initialization says each element in this list, this initializer list, is its own element with its own value. So in this case, one element, value 10, 10 elements, value 0. Okay. Non-empty initializer lists prefer list constructors. So if we use list initialization, we're giving it that many elements with that many values. But if we use direct initialization, at least with one argument, then we're simply telling it how many elements to have and the values they should get, which will be automatically 0. I can't listen to English. That's good. Too loud. Good. All right. The point here is because it's an initializer list and it's not empty, then it prioritizes the list the list constructor. That way it doesn't conflict with a that way it doesn't conflict with direct initialization, the parentheses. So if we have parentheses with one value and then list initialization with one value, the list will prioritize the list initialization where it does member-wise initialization and it says, hey, for each value in this list, there's an element in this array. Basically, the size is set to however many values are in here. Versus, with parentheses, the size is actually, or the length is actually this one number. This number is how many elements there are, and they all are value initialized to be, at least for integers, 0. For strings, they would be just empty string. Which is just 2 quotation marks touching each other. There's nothing there. And the point here is so that this isn't an ambiguous result. List prefers actually initializing the vector, whereas direct is for the size. So it seems like if we wanted to create a vector of some size in advance, we do it with direct, but then we can actually initialize it with 10. Do we have to do copy initialization then? Because, or just copy assignment after we do that? I mean, we're just using int here. I'm trying to be specific about why I'm including things. So this one has 10, and then x is... And what if I just don't specify the rest? It just updates the first. Extra space. Excuse me. Excuse me. So I'm guessing this is 10, 20, 30, and then a bunch of 0. Wait, hold. What happened here? Ow. What? The size is 3. Okay, size is 10. Oh! What? Size is 3. Why the fuck is x not being value initialized to 0? Hello? What the fuck is happening? Oh my god. What in the fuck was happening? Dude, x gets value initialized to 0. But the condition here was... For some reason it was left shifting this amount. And then evaluating to see if it was true or not. I don't know what it was doing. I really don't know. Okay. Okay, now it's cool. I just had 2 less thans there. Okay, so copy assignment actually changes the size. Interesting. Okay. That's something I didn't know yesterday. And is this going to be like reinitialization if I remove this? Yeah, it's already been initialized, right? Yeah, you have to do that during the definition. You can't use that syntax. Probably have to do copy list initialization, I think. Because we're copying a list over to it. Ooh, fruit's getting there. Still too cold. Oh. Yes. In the definition, so when we're creating, why are we saying when a class types, definition, so when we're defining the object, if that definition, which is where the constructor gets called, matches more than one, so if we pass in one argument here, we get an ambiguity error. I prefer the list constructor, okay. Over all others, okay. Yeah, that makes sense. Alright, I can't listen to this. Of course, this is English. That's the only thing about this guy. He has English singers. This is terrible. No. The fuck? I'm getting banned. Oh, that makes sense, because if the list constructor takes arguments of a single type, but there's any other constructor that takes arguments of a single type, so I guess it doesn't care. There's a way in the constructor. I wonder what these constructors look like. There's a way of... I don't know how the member initialization happens, the member-wise. So it says, hey, we create a new... What is the process by which a new element is actually created? for each element in the, or for each argument in the initializer list. Because it seems like there are two constructors and they take an initializer list as their argument or as their parameter. So when you look at the direct initialization, or the direct initialization one to specify the size, that one takes just one argument of one type. But if the list constructor takes one parameter, or it has one parameter of one type, but it's just a list of them, then it still conflicts. Okay. That is an initializer list. Standard vector does have a list constructor, so that we can initialize it with a list. Make sense? And initialize a list. If the initializer list is empty, the default constructor happens. If it's non-empty, the list constructor happens. And if we don't use the list, then whatever other ones happen. Not initialize a list, copy initialization whole. So there's an explicit constructor that takes an initializer list, seems like. It's not an initializer list, and we have an explicit single argument constructor. It creates it of size, and then for each one of those elements, value initializes it. Now it's an initializer list of one value. Now it's copy initialization, but it's of an initializer list, so it matches. Now it's direct list, a direct initialization with an initializer list. So the point is that the argument is still an initializer list in all those, but then we have an empty one and then a copy empty one. So if it's empty, default constructor is called. So there's default to say size 0, value 0, or value initialized. And then there's single argument, not an initializer list. And then there's initializer list. Because it's being passed into, well, I'm curious why. I mean, I guess it's like operator overloading or something where the operators have to match perfectly so that copy initialization doesn't work. It could be the list constructor, or it could be that single type, single argument, or well, that single argument one that is of one type. But in that case, list is preferred over others because it's not empty. Excuse me. So the list constructor is non-explicit, but the single argument one is. Gotcha. So there's single argument, and then there's the other. Okay. If it's not explicit, then we can. So is this somehow? I don't know what the conversion even is, because we're giving it an initializer list for case v4, but we're also doing copy initialization. Oh, because explicit disallows copy and direct initialization. Gotcha. Okay. So it's not that it's converting, it's just that it prevents certain types of initialization. But only the single argument constructor is explicit, which prevents single argument disallowed because it's explicit. It disallows this type of initialization. Single, I guess it's just copy. Direct, same thing, but with direct initialization, allowed. It's explicit. List initializer. Fuck. I haven't eaten in 48 hours and then I just ate, so the food is taking a while. I can't speak properly. I'll try and be a bit more articulate with my words, be a little more careful, more precise maybe. Okay, and then we have a list initializer that does still match the single argument constructor, because there's one argument in here, but because it's list initialization, it is preferred somehow, I'm not really sure, it is preferred in the constructor. And then here, this is single argument, but the explicit one is not chosen because 1, this is copy initialization, and 2, the list constructor still works, and there's not no match, compile error like here, because it's not explicit. And then apparently this is alternate syntax for copy initialization, which copy with a list initializer is fine. I feel like Tyler won. My God. And then default and default. Okay. Because direct, copy, disallowed, not explicit. Well, explicit doesn't match because it's explicit. List, default, default. Okay. Yeah, that makes sense. So if we don't have a list, well, I mean, we would hope that there's a list constructor because we want to we probably want to, we want to be able to handle scenarios where we initialize the array with multiple elements and we don't just add them on sequentially. It would be nice to be able to say, hey, I'm creating a standard vector of this character, and it has 3 float values or some number of float values. Yeah, especially I think for graphics programming, like you could have a class and just call it triangle, and it just has a one data member, which is a 3 element, so size 3, n equals 2. Or I guess n is 3, but the final index is n minus 1. Called triangle, and 0 is the top one, and then whatever. Each of the 3 elements is one of the 3 pieces in the triangle, the 3 vertices. And we would want to initialize them not separately but at once. Because I imagine the process by which we initialize one integer in an array is probably pretty cheap. So most of the cost in the initialization is probably just the cost of initializing anything to it. So if we initialized them piece by piece, I would guess that that's probably 3 times as expensive as initializing one piece. So we may as well Just initialize all 3 pieces in one go. If a class doesn't, yeah, behavior could change. Here we go, hold on. If it doesn't have a list constructor, but then one is added later. Well, yeah, because if one is added later, non-empty list arguments will then call the list constructor over the other constructor. Yeah, makes sense. Yep. Interesting. You have to specify the type, because this is not parameter deduction, this is argument deduction, brother. It has to be known at the time of the struct definition, which is compile time. So we could use list, do it with a temporary that has size 8. Or capacity. I gotta blow my nose. Are you fucking me, dude? Oh, come on. I hate being weak, man. When I don't have food in me, I'm not coordinated. It's annoying. I gotta get back on analogy pill. Fuck it. Some drink got condensation water all over the place. Back to taking an allergy pill. Turns out I have more than I thought left over. Just a different brand. Oh, excuse me. So we can have constant ones. So maybe, yeah, I mean, if you have world origin, and you could say get world origin, and it just returns the vector with 0, 0, 0, that ensures it's unchangeable. Well, yeah, I didn't think you could even put qualifiers here, but maybe I'm wrong in other cases. Okay. Standard array can be constant expression to be messed around with at compile time. Not standard vector. And the vector itself's const. Makes sense. Is from its own const, not its elements const. It's not that, oh, you have 4 values that are constant, you initialize a vector with them. Because these are literal consts, so you think, oh shit, we can't change this. No. Oh, well, this thing is const, so we actually can't. That's true. Damn, so long. I've heard this before. Why is it called a vector? Makes sense, because normally we're talking about a vector, like vector in Unreal Engine is what this vector means. A geometric vector, where we say something with a magnitude, so we can multiply it by something and it will inherit that size. So if we say like speed, a speed vector is a speed that has an amount, maybe it's 0, but it has an amount and it has a particular direction. Which in Unreal, the direction is actually part of the vector. It's this much in the x, this much in the y, this much in the whatever. But if I multiply something by something equal in all 3 directions, it takes a speed vector and just makes it bigger or stronger. Or bigger or smaller, sorry, wrong word. I'm still fucked up. I can't wait for this food to actually hit my system. Okay. Oh, true. I forgot 9, duh. I was thinking 1, 4, 16, 25, 49, but it's not. Using class tempo argument deduction? That's too easy, right? I need something different. This is... Hold on, let's go back here. Excuse me. Oops. Yeah, because this is not a type name, so it can't perform deduction like that. Okay. Cool. One element 5, 5 elements 0. We can't do it unless it's given an initial as a list. Okay. Alright, I'll stick with giving it explicits then. And there's the proof. List is one value of 5. 5 is direct is 5 values that are 0. Yep. And specifically value, but I mean which is 0. Define a standard vector. Oh, using an explicit. Okay. To hold the high temp. The fuck are you asking? Bro, why is there something in my eye? Please. Just want to live in peace. That's all I want right now. Untainted. Oh, we're saying a standard vector to hold the high temperature. Who gives a fuck about this? Oh, are we talking about set precision? For each day? So 365? Really? Get some juice real quick. Well, I mean, we could do float, but I'll just do this because it should be more efficient, I guess. It's the standard float type for 64-bit. Okay. Container, what is it? What's the word for how much? Size 365, length 365. Volume, I don't know. I mean, do I want this in a class? I mean, I can have a function to update the value. Bunch of ways we could do this. What if I did this as a class? I don't want it as the class template though because I need to give it a size. And if I pass it a size, then it's going to think that we're talking integers for the values, but they're going to be doubles. So we'll do oh fuck, but we need to specify the size in the beginning. Okay. Sure, it takes a size double and it's called temps and it's initialized with a standard vector double of size 365. And then we have public. I guess I'm not gonna fuck with the constructor. And then we could say void set, or we'll void get temps. Excuse me. Well, I guess we just get a const reference, huh? And we can just return the guy. And we have int element double value, double temp. Temps element. Ah, fuck, this is gonna be, oh, it's actually okay with that. Not, okay. Fuck, I knew there was gonna be some bullshit. Alright. Okay, so we could create a weather data with, well, hold on. Yeah, nah, because we don't have it, hold on. Well, what even happens if it, what is this error gonna be? No constructor. I don't know what a list constructor would look like. Can't I just make the Oh, we don't have a member initializer, so it only has default. Okay, so it's default like that, and then we could say x, hello? Why can't we type x? So I could set 5 to be 3.4. What was precision? No. I don't remember how to set precision, but I mean, in this case, we could just do something like this, and then we could have another function that just prints it, and it takes a that way it can be overloaded instead of having it be a member. Well, a friend could work, or a data member could work. I'm just gonna do print, fuck it. Has an implicit this, it's fine. Okay, we're gonna say for unsigned in I like x. X is less than temps.size plus x. Uh-oh. Oh, well, we didn't, that's good, we didn't call it. I was wondering why not. Printed everything. Oh, the problem is I meant to set the the 5th one. Cool. Okay, that's cool. Anything else we could do to make this better? He starts with a default size because he's default initialized. We don't have any user-defined constructors, so we can't initialize him with a list right now. So in this case, assuming he's a list constructor is actually wrong. He only has a default. We can return him if we want to send him somewhere else, but I mean, in this case, it's not even needed. And I mean, we could say get index for these and then print each index, but well, I mean, sure, if this is the public stuff, we probably want this to be like that. So let's say, we'll say get temp, and we'll specify unsigned int element. Return. Oh wait, hold on. Actually, fuck this. Default constructor. Setter. Nah, it doesn't help. Double get temp, and we get unsigned int element. Wait. Oh, I was just being stupid. Okay, const return hold. Oh, okay, yeah. It's fine for this one, the getter, to access the private data member. It's the print we don't want to, just in case. So if we change the print, then or if we change the private data member, the implementation, sure, we'll have to change these the getter and setter, but at least we won't have to change the printer. And now this is instead just get temp X. Hold. The fuck is happening? Oh, I don't know why it didn't like that. Okay. Same result. Cool. All right. Instead of public implementation, which could have been better. What was better here? I mean, this could still be const expression potentially. Same here. Maybe not. Yep. Okay. The static stuff. This is fine. Okay. Yeah, I mean, it's easy enough. We know that this is just saying the double type, and then this is saying the size. Yep, cool. Okay. Okay. Yeah, this would be cool. Integers? Cool. Or, well, integral values, but sure. You drink? I mean, if we want them to enter 3 values, then sure, we can do this. And then we'll call fill vector X. And then we could do void fill vector takes a non-const standard vector int reference X. And it says, forgot, need IOStream. Enter some number of those. Yeah. Okay, yeah, it should be fine. Okay, and then we could say for unsigned and X, or I'll just say unsigned and Y because it's going to shadow it otherwise. Maybe it's not the same type, but I think identifier still. Unsigned and Y, while Y is less than X dot size. Excuse me, increment Y. Extract to XY. I want to say I is better. And then Cool. Increment. Place times equals x of I, x sub I. One 212. Uh-oh. Sum product 0. Oops. Uh-oh. Oh, duh. Product needs to start at 1. That's fucking stupid. Two times 7 is 14. Times 10 plus another 14. Yeah, 140 plus 14 is 154. Cool. And then that's just 9 plus 11. Cool. Works for me. Can't make these guys none of these can be const expression. Sad. Because they're using runtime only shit. These objects that are only created at runtime. Allegedly. Can be made static though, because no other files are using them, but doesn't matter here. I mean, if you specifically wanted it to only be... Well, I mean, if we wanted to just update this so that it was... Could just say... Okay, and we'll just call this print triad. Well, I mean, I'd rather just say... If we call print triad and it gets triad, so void get triad, or get triad. So we could say the point here is, or get triad makes it, so we'll just say guess we want to store it, right? Standard vector int x is initialized with get triad, and what this returns is okay, it creates a guy of size 3, and then I mean, sure, we could do x is 0, x is 1, and then x2, and then return x, and then for unsigned int I is less than x.size, increment I, we could say int sum, int product, and then say, doing to multiple things, we need a complex statement. Sum is itself adding these guys, so xi, and product needs to start at 1 times equals xi, and then sum, oops, product, if I could fucking type, product, $21, 36 times 6, yeah, okay. Yep. Minus 81, yep. Okay. Yeah, 810 minus 81 makes sense, yeah. 219, or 719. And if we wanted, we could actually just make this guy const too, because we're not changing him, we're just initializing him. May as well. The point here is we're saying, hey, starting at the first element and going through the entire size of the vector, of the standard vector, of the array, add and we could initialize sum and product with the first element of each, but this makes more sense. We just start sum at 0 and product at 1. And then we say, okay, sum starting at 0, each of the elements is added to it, and at the end we get the sum, boom. And the product starting at 1, each element multiplied by it, boom, you get all the elements multiplied by each other. And then sum and product, okay. Or you could just hard code it and say, hey, we have an array, it's a size 3, enter 3 integers, extract 3, and then add them like that. Sure, I prefer just going ahead and doing looping. This is a short one. Okay, never mind though, just no comments. There aren't any comments. Alright. Subscript an array, meaning like x1 to get the second element, x0 to get the first. Oh, sounds like Hell's Paradise. Just gonna use the subscript an array to access an element. Other ways to access them, and different ways to get the length of a container class. So getting the length and the ways to access the elements. Okay. A major mistake the designers made. Well, we've already seen that a little bit, because I have to create an unsigned integer to pass it in. I can't use unsigned values when I'm subscripting. And I guess it's because we get an implicit conversion, but if we say for I is 1, it already knows that it's signed. You'd think it would still convert, but I guess not. The data type should match the data type used for storing the length of the array. Here we go. For subscripting, should match the same data type for storing the length. And I think that's a size t. Because if the size of the, which is, I think it's a long, it's an int64 for size t. But if it's not for the subscript, then we can't even index the whole thing. I mean, I've heard that some arrays, you can use negative values to go back. So -1 is the last. -2 is the second to last. I mean, I can see it if we're talking efficiency purposes, meaning, or memory efficiency, where if you have if you want an array to be larger than the maximum amount of, if you want more positive values and you can't use negative values, well, you may as well make it unsigned, because then that doubles how many values you get for your memory. Because we're allocating 4 bytes to an integer, but we can only use the 2 bytes of term in positive because we can't use the negative values. Makes sense? The extra bit. Oh, I gotcha. Because you need 2. You need to make sure it's not too big and make sure it's not negative. But now you don't need to check if it's negative, because it has to be positive. The wrong choice. Excuse me. Meaning, yeah, and the point is that it's not preventing non-negativity. It's not like it's an assert that's saying, hey, if it's negative, stop the code from running. Instead, if you put in a negative value, it's just going to do underflow. Yeah. Do we need one more power of 2? I mean, because 2.15 versus 4.3 billion. which is why we got the error earlier. But we have an assert for VS22 though, luckily. Hmm. Yep. Yeah, we know this is just standard narrowing conversion definition. Yep. For example, we have assigned in 5 and unsigned in US. If it's not, if int s is const expression, then we're okay because it'll check, hey, it's not actually out of range, we're fine. Hmm. And the copy initialization happens here because that's how we initialize those. Yep. Yep. Yeah, for me, it's an unsigned long. Are we actually gonna? Oh, we better not have to do that. I'm thinking that we're gonna have to do something like this. Alright, whatever. Hold. Yeah, it can't even evaluate to a const. Hold. We can't even end. Well, duh. Yeah, we can't even do that. Never mind. I was somehow retardedly thinking that I could create a const expression integer, copy them here, and then use this to subscript, but we can't. We can't even do that. There's no way to do it for the looping. The length of and the indices, so the index that we use to actually get an element, are of size t, unsigned long long. Makes sense. It says, hey, on this implementation, size t is a this, or it's a this. Mm. Okay. A standard allocator. Thus, the allocator determines how much memory can be allocated. The allocator is limited by size t, and if size type is determined by the allocator, size t determines allocator allocation, determines size type. Gotcha. Excuse me. And if it can allocate up to size t, excuse me, then the size type is okay. I'm functioning at like 65% right now. I can just feel it. Makes sense. If it's defaulting to size t, it's only not going to when it doesn't, when the allocator doesn't allocate equivalent to a size t. Okay. Static? Oh. Oh, okay, yeah, we can't do that. So it's just standard size. Okay. The length using size, even though we don't normally say size like that, it's interesting. That's what I was worried about earlier. I was expecting the size to be 20, because 5 integers. But it's not, it's 5. Yeah. Still don't know what a decayed C style is, but standard size can be favored over the dot size. Gotcha, because in the case where we're using multiple types of arrays, standard size would yield the fewest errors. Oh. Makes sense. Yeah, so if we're in a function template that uses an array type, and assuming that they can maybe be converted to each other or just passed in as is. Oh, as a temp, that makes sense if it's a function template, because we're accepting a C style array and creating a specialization, well, an instantiation, a specialization, well, not an explicit specialization, a specialization that is automatically created, an instantiated version is generated specifically for a non-decayed C style array. And if we use standard size in there, well, there's no dot size member function, so it kind of makes sense. Okay. Oh yeah, because they were saying these decay to a pointer, meaning that if you use it, it returns a different. Is it like using a member function for something where we decay from getting from the value to from the object to just an integer if we call something dot size? So if we're saying a non-decayed C style array, we're passing the entire array, not just a pointer to one piece of it. Yeah, because an int can't hold all unsigned values. Oh shit, C plus 20. Standard S size. I'm curious to see the way that we're going to use loops and what we're going to pass into the subscript operator to actually access the different elements of the array. So that we're not mixing signed and unsigned. Are we always going to convert? Or are we going to... I don't know. Better example here would have been just to initial. Well, actually, if that's big, then we might even still get a narrowing because I'm assuming that's going to be too big because it's large. Yeah. Yeah, exactly. Yep, there it is. Exactly what I was thinking. Excuse me. And there's the counterpart. We're still doing the same thing. Static cast still. Super mega helpful. Cap. Auto. Boring. Because I'm... Oh my god. Music's loud. I wasn't even sure I was hearing that. Yeah, we're not doing type deduction, bro. Fuck off. And so, are we going to get a new version that actually does do bound checking? Okay. Alright, done for a little.